Fine. So we will see how this actually how these particles are it is arranged. Okay. And when we see this solid, see, consider here the solid, and yeah, here it is. I hope you are able to see this. So, this is solid actually. Solid, it is solid particles. How it is arranged is actually very, it is very packed, and it depends on the solids. Actually, this packing it will be very high. For example, if I am taking the example of a ice may be not maybe, actually the solid particles. Okay, I can consider here. Solid particles, it would be arranging in this way. Okay. Because it's less dense, right? Actually, if you put the ice in the water, the ice it will float on the surface of water. Okay, sorry, howling sound is coming. And but on the other hand, if I take some diamond, take the diamond, the particles will be very, because its density is very, very, very high. Okay, so the particles, it is very tightly packed. You don't find any space in between these particles, and the packing of these particles, it is very, very tight. Okay, it's very tight. It's very, very tight. So this could be the case of diamond. So depends on the solids. The packing will be different. Maybe it will be very, very tightly packed. Sometimes it will be little bit loosely packed. But whatever it may be, in the case of solids, actually the packing it would be high. Okay. But on the other hand, this is the case of solid. On the other hand, for example, liquids. Okay, here the gases, here the particles, let this be water or any liquid. Okay, I can put it as hexane, C6, H6. Sorry, let it be not hexane, let it be water itself. This is a common solvent. Okay. Hexane it is C6, H14. Write the formula, I will write water. So here the water, it is little bit loosely packed, and here the particles are, it is little bit free to move. It can move from here, it can move from here to here, from here to here, from here to here, from here to here, and it is able to move from one region to another region. Okay, so it is somewhat it is free, but when you take the case of gases, the particles are very distant apart. At least in the case of this liquids, I can write the case of liquids here. So the interaction between these liquids, actually it is a little more good. The molecular interaction. There are different types of interaction except between these particles. It's sometimes ionic interaction, sometimes covalent interaction, sometimes water Walsh forces. Okay. So the attraction between these particles, actually the force of attraction between these particles, it is, in the case of liquids, it is pretty good. On the other hand, for gases, the interaction, there is no interaction, because this is very distant apart. In order to have actually these two particles, it is very, very distant. See, for example, this is gas, this is liquid, so it would be little more closer. This is solid, this is very close, so there is strong interaction. On the other hand, liquids, actually the interaction is little bit less. But between gases, there is almost no interaction will come actually. How there is interaction? Because two particles are very distant apart, and it is almost not easy to have strong intermolecular attraction. So, what will actually, in fact, one more thing, these particles actually, it is always in motion. Motion in the sense, there are different motions. Sometimes it is in translational motion, that means moving from one region to another region. So it is in translational motion. Sometimes it is in vibrational motion. Sometimes it is in rotational motion. Okay, these particles always in rotational motion or translational motion or vibrational motion. But for solids, actually there are solids also, there is some motion, but this motion is not that great. Liquids, it is even more, little more freedom, so it is moving here and there. Gases, it is very much moving. So what you need to know is, what will happen when we are melting a stuff? See, when melting happens, okay, solid, so these particles actually, when melting happens, okay, so these solid particles, you know, when we are melting, think that you are heating. When you are heating, okay, these particles, it is always in motion, it is going to have a moving. So it moves, and you know these particles, it will distance apart, okay, the force of attraction between the solid particles moves away. And again melting, we can call it as vaporization. Okay, vaporization, actually what will happen, no? So again these particles, you know, it is constantly moving, it will faster moving actually. Suppose here the temperature I am keeping it as 50 degrees Celsius for melting. Here actually I am keeping 120 degrees Celsius. Okay, so when it reaches more than 120 degrees Celsius, these particles, it is actually very restless. It is constantly in moving motion, so that, you know, these two particles, it will never come close to each other, and which is in the case of gases. Okay, so once it changes into liquid, it will keep on vibrating, and the motion will be very fast. Once it changes into liquid, even it is faster, even it is very high. Okay, this is actually what is happening. Okay, this is actually what is happening with the when what happens when we are melting. And when we are increasing the temperature, it will initially melt, solid will initially melt, and again it will change us into gases. Okay, so if I ask you a question, in which case in which case actually the motion is faster, okay, movement is faster, it is nothing but in the case of gases. And opposite, on the other hand, you know, like if I am decreasing the temperature, say from 120 degrees Celsius to 50 degrees Celsius, I am decreasing, it will change us into this gas particles, it will change us into liquid. Again, if I am decreasing the temperature below 50 degrees Celsius, okay, this liquid particles, it will change us into solid. Okay, this is actually is happening in the case of when we melt and when we cool. Okay. So now we will have a question actually, how much heat it would be required for melting, right? Actually, see, okay, I agree that when you take some this ice, see, when you melt it, okay, so it will melt at 0 degrees Celsius, but does it mean that all the things around you, it will be melting at 0 degrees Celsius? For example, if you consider some diamond, okay, if you consider some diamond, it doesn't melt. It's not going to melt at 0 degrees Celsius. Even if you increase the temperature to say 100 degrees, 1000 degrees also, it won't melt actually. You need to reach more than 3000 degrees Celsius. More than 3000 degrees Celsius for the diamond to melt. Only then diamond will be melting. See, what determines something is melting at a particular temperature? I will tell you. See, like you know, so here you know this is a particular solid. Let it be whatever the solid it may be. So, okay, let it be diamond. Okay, let it be ice itself. And on the other hand, you know, this is actually a diamond. Okay. See, first thing is, you know, how much it is, what will happen when we are melting. See, when we are melting, actually, see here actually suppose these are two particles. there will be some strong force of attraction between these two particles. When you are melting, actually this particle, it will start to vibrate. It will have it will go on vibrating. So what will happen actually, because of the vibration, because of the force, this, it will break apart. So what will happen? So these two particles, it will be away. Okay. So it will go on keeping away. Okay. So this is what is going to happen actually. So if the force of attraction between these two particles, if this is very strong, then you need to apply more and more amount of energy. Just with the, say, 100 degrees Celsius, just with the 500, it's not going to melt. You need to apply a lot of energy, then only this force you can break it. That is the same thing happens with the ice and a diamond. See, in the case of ice, actually these particles, these water molecules, it is held together by hydrogen bonding. Or sometimes van der Waals forces, right? Mostly hydrogen bonding. Okay. So on the other hand, actually hydrogen bonding, it is a very weak force of attraction. On the other hand, between this diamond and diamond, actually the particles are nothing but carbon atoms that is held together by covalent bond. So just with the mere heating, you cannot break the force of attraction between the carbon atoms in a diamond. So now you are familiar, now you can understand why more energy is required to break this bond in the diamond, right? Okay, it is between some strong friends, thick friends, no matter how much it comes, whatever happens, you cannot break the force of, their bond between the two people. Okay, that is the same thing. And now we will see what is the effect of reversing the changes. See, I will tell you. See, of course, I agree that this is some ice. When you are melting, when you are heating, this ice, it will melt, and the particles, actually this ice molecule, it will keep on vibrating, or translational motion or rotational motion. So it will go on to, it will go on to melt. So, the particles, it will try to remain distant. Here it is very close, right? Actually, here the particles are a little more closer. Okay, but here, when it is heating, actually these same particles, due to the vibration, these particles, it will distant. Again, if you are heating, even it will remain distant. See, it will somewhere here, and here. So here it is nothing but this process, converting the solid to liquid. We call it as melting, and converting that to, this is called gas. Okay. Now, of course, when we are heating, if these changes are happening, okay, then actually when we are when we are cooling, the opposite also can happen. If you cool these gases, okay, then actually what will happen now? This gas will turn to liquid. For example, I hope at least some of you might be cooking, right? So maybe perhaps when you are boiling the tea, let it be a teacup, and think that you closed it with a lid. Okay, so this is a tea. Yeah, this is a tea, and I am drinking. So what will happen now? When the tea is hot, you are keeping this lid. Once after some time, if you open this lid and see, it will contain some amount of water droplets. Obviously, you will see some water droplets. Actually, why? Because when it is cooling, this vapor, it will try to condenses and stick on there. So, if you cool the gas, it will come back to liquid state. We call that process as a condensation. condensation. Again, if you cool the liquid also, it will come back to solid state. We call it as freezing. Sorry. Yeah. So these changes, it is reversible. We can't say that these changes it may not be reversible. If you just reverse the changes, if you just decrease the temperature, okay, these whatever the changes happens, it will come back. It will come back to its older form, its previous form. Okay. Okay. Now one more thing. One more thing. What you need to know is just sometimes you may think like okay, just by cooling it will come back to liquid state and it will come back to solid state. Not like that. In some cases, for example, even if you cool, it will not happen. You need to apply, for example, you say some gases. See, this is oxygen gas. You are lowering the temperature minus 100, minus 150, minus 200, minus 180. Even then this oxygen it will try to remain as a liquid unless you apply some pressure. When you apply pressure, see initially if it is like this, okay. When you apply pressure, so this is the initial position. When you apply pressure, okay, this piston will come here and these particles it will try to occupy a lower body. Okay, so the space within that piston it will try to remain in a lower space. Okay, so this is what will happen actually when we are condensing. And by the way, we will have some questions and which we will answer right now. Yeah, the first question is using the idea of particle, explain why you can pour liquids and the solids expand on heating. Okay, I will tell you why you can pour liquids. Because simple reason, the force of attraction between the liquids are very less. So the particles can easily flow. If the force of attraction is very strong, then it cannot move. It cannot move here and there. If it is weak, then it will keep on flowing. Okay, and now second question is solids expand on heating. Yeah, right. Because when heating, it will acquire more energy. See, for example, yeah, here. So let this be a solid particle. Solids. See, when you heat it, what will happen now? This will acquire more energy. These particles, it will acquire more energy. So what will happen? This, it cannot occupy in a smaller space. It will try to occupy in a bigger space. Okay, so it will acquire the energy to move distant apart. Okay, so it will come back here. Right? So this is what is happening in the case of when we are heating the things. And draw a diagram to show what happens to the particle when liquid cools to solid. I can just reverse it. See, this will happen. Yeah, that means actually this is liquid. This is solid. Okay, so when you are when you are cooling, what will happen is, so this process we call it as a liquid to solid, we call it as a freezing. Okay, so the particles, if it is free, here it is, in the case of liquid, if it is moving, if it is vibrating like this, okay, the vibration will remain slow and it will try to occupy in a more compact body. Achha? So that is what happens. And now, okay. Next question is oxygen is the gas we breathe in. It can be separated from the air. Right, of course, we can separate from the air. It boils at 219 degrees Celsius. That means the boiling point is 219 degrees Celsius minus. Okay, and the freezing point is minus 183 degrees Celsius. Okay, that means the boiling point is minus 209 degrees Celsius and the freezing point is minus 183 degrees Celsius. Okay, fine. Now the question is, in which state is oxygen at 0 degrees Celsius? You guess it in what, whether it is in solid state or liquid state or in gaseous state. At 0 degrees Celsius, what would be the state? See, in order to just to melt it even, that means from gas to liquid state even, you need to go to the range of minus 209 degrees Celsius. Okay, I mean gas to boiling point, right? Yeah, gas to liquid even. So at 0 degrees Celsius, obviously it will try to remain as a gas. And at minus 200 degrees Celsius, it will try to remain as a liquid. Okay, it will try to remain as a liquid. Fine. And how do you turn oxygen gas into solid oxygen? Simple. Two considerations are important here. You may think like, okay, how to turn oxygen gas into solid oxygen. You may think like just by decreasing the temperature it is possible. No. There are two conditions actually, two parameters comes into play when we are converting the gas into solid. So here, suppose oxygen is in a container, you need to apply pressure. First thing, then actually you need to lower the temperature. Two conditions has to come into play. When you lower the temperature, these gas particles inside this, it will try to, if it is vibrating and moving faster, it will slow and it will try to remain slow. When you apply the pressure, what will happen? These particles, it will try to occupy in a lower volume. Okay, it will try to occupy the state in a lower order. Okay, so this is what will happen in the case when how can you turn this gaseous oxygen to solid oxygen is two things. Just apply more pressure just to decrease the temperature. These two things if you do, gaseous oxygen it will turn to solid oxygen. Okay.